I don't know, something is happening with my laptop. I may need to change it. It's getting disconnected. Something is happening. Okay, all right. So can you just remind me what happened in the last lecture, like what we did in last lecture? Anyone?
Questions are based on electric field
Right.
variety. So yeah, last thing we did was
Yes, sir.
electric.
Uniformly charged.
Yeah, uniformly charged circular thing. Yeah.
Okay. Okay. So the continuous charge distribution that we started, right? Electric field due to continuous charge distribution, or are we doing the discrete only?
We did
Maybe
continuous last lecture.
continuous, no? Just let me confirm.
Uniformly. Yeah,
Confirm, right. I must have shared something the sheet and right. So we have already started the electric field due to the continuous sheet, and we have done quite a few questions. All right. So we have done due to the ring part, the circular arc, and line charge, right? So these two things are done. So we'll continue some questions based on the same. Yeah, that's the problem. Can you see the 3333?
Yeah.
This is, I'm not doing it.
So
My laptop.
it was happening in we had a PACE class in the morning today online.
Okay.
And it was happening to our teacher back then too. Like I think it's some app with this Zoom whiteboard thing.
No, it's not Zoom. It's like happening with my laptop also. Some virus has entered. Maybe some sort of virus has entered, I think.
Maybe it happened to my math teacher in PACE class today. There were like random lines being drawn throughout the board.
Okay, so there is some cyber attack, no? Maybe. So let's hope things will be fine. Else I will try to change the laptop. If even persist there, it means there's some attack. And as you're saying, it's like a big attack. Okay, whoever is using the Zoom, maybe through Zoom they have entered. Huh? Okay. Anyway. So every time a 3 comes, you can ignore the 3. I'm not writing 3 at all.
Yes, sir.
So we have a line charge in shape of a U, as you can see. The bottom is a semi-circular portion, which is seamlessly connected to the two semi-infinite line charge. The radius is R, and O is the center. So we are supposed to find the electric field at the point O. Just as a quick recap, you should remember this again. For any semi-infinite line charge at its bottom, at a distance d, we have equal field in the direction perpendicular and parallel. These are equal in value. And both value comes out to be how much? K lambda by d, if you remember, right? And similarly for the quarter, if you do it at the center of curvature, so if the lambda is the linear charge density, then it will have component like this and like this respectively. And both is again equals to K lambda by R. You will take R here. So why this is important to remember? Because every given question can be broken down into semi-infinite and quarter rings in most of the cases which you will face. and then applying their answer will be easier for you to get the net answer. Okay.
Yes, sir.
So you're supposed to find the electric field at O in the actual diagram. Okay. So try for a while, maybe 1 or 2 minutes, then I'll solve it. Done, guys?
So we have to find net field.
Okay. What else you will find?
Yeah.
The net field at O will be how much? That's the question, right?
Hmm.
Okay. So the
Sir,
way
I
to
think
yeah.
0.
Yeah, 0 is the right answer.
Yeah.
Very good. So you can divide this into 4 parts. Then it's pretty easy for you to understand. So if you look at the first part, which is a semi-infinite, it will create a one field right and one below. So I'm taking the arrow method like this. I'm showing the arrow, and every arrow represents k lambda by d. Now that is the crux. Okay. Now if you look at the 2, which is a positive charge, it will repel the O point if you assume some positive charge there. And so it will create the field up and right. Okay. But 3 will create a field in the direction up and left. Can you see that?
Yes, sir.
And the 4th will create the field left and below.
Left and down. Yeah.
And you can see all 4 will cancel out together, like all 8. Net field turns out to be 0. So that's pretty simple. Anyone having any doubt?
No, sir.
No, sir.
So similarly, we can have a next question like this. So imagine we have quarter. Okay, those are the part. And we have 2 line charge which is in continuation with this quarter in this particular shape, as you can see. And lambda is the linear charge density, and this is you're supposed to find the rectifier at all. Okay, so do it. Questions clear? So assume R as the radius.
Yes, sir.
So again, you have to do the same trick, and you will see that the answer is pretty much obvious. Tell me how much you get. So anyone who has not understood the previous question. Kanu, you understood the last question?
Yes, sir.
Good. So solve this. This is very easy. No, it's not 2k lambda r for sure. You must understand it's a vector equation. So vector notation means you have to take the vector resultant, right?
Yeah, yes, sir. I'll do it.
No, but it won't be K lambda bar, no? In the directional bisector is correct, but the answer will be something different, right? So here, of course, you can see the first, if I just divide into 1, 2, and 3, the first will create right and below. The quartering will create a right and above. And the bottom ring will create up and left.
Yeah.
So what is left is one right and one up, right? Because 2 minus 1 is 1 and 2 minus 1 is 1. So we have left with one on the right and one above. And because each value is K lambda by R, so net will be how much? Root K lambda by R.
Sir, root 2, no?
Root 2, yeah, so root 2 K lambda by R. So the E would transfer to how much? Root 2 K lambda by R. Is this clear?
Yeah.
Anyone having any doubt in this, please do let me know. So let's go to the third problem. Now these all are question in single plane. So now we are going to move towards the three-dimensional problem. You can see one semicircular ring is in the YZ plane and another is in the
XY
which
plane.
XY plane, XZ plane.
Yeah.
So what you're supposed to find? The net electric field at the origin. Let's keep it lambda. Radius you can take as R, both. Now you cannot just solve by adding or subtracting. What you need to do is very simple. Find the net electric field with direction due to each plane and then take the resultant of those two answers. Okay. So I hope you can do this. Not very difficult. Use I cap J cap notation to properly express your answer.
sir, I sent the answer.
Okay. Minus k won't be possible. No? How minus k is possible?
Yes, sir. Yes. My bad, sir.
So what will be that? Tell me.
Yes, sir. No.
So what will be the answer? If minus k is not the right answer, then what is the answer?
Minus I.
Minus. That's correct. Very good. So the first the ring in the YZ plane, the Y is the line of symmetry. So the net field will be in the opposite direction to the y-axis, which is minus j. And for the ring in the xz plane, the x is the line of symmetry, so the answer will be minus x direction. And for the half ring, the answer is how much? 2k lambda by r. So that minus I cap minus j cap. And now if you want to find the modulus, I hope this is clear, guys. It is clear.
Yes.
So you can identify the charge distribution. Just for your idea. So you can see that two semi-infinite wires along with one semicircular wire, and all are joined like this. Uh, the first part of the wire is, or you can say, line charges in the xz plane, and the remaining are in the yx plane or xy plane. So the question remains the same. Can we find the electric field in vector form? Now try this out. As I said, always break down things into different planes, then check their plane and try to think of the direction. Hopefully you get the answer. If you see every part in a plane, you can answer the question easily. So if you look at the very first part, let me just make this first part. Can you guess which plane is this? I can take the entire semicircular ring as part 2 and this semi in front as part 3. So tell me guys, what is the value for the first part? For semi-infinite, which plane is this? Hello, hello, 1, 2, 3.
It's YZ,
This the first part is in which plane?
XZ.
X,
XZ plane.
X.
Very good. So the answer must have the X and Z component only, right?
Yeah,
If the charge is in the XZ plane, then the electric field equivalent is having the component only in the XZ plane. It cannot have the
yeah,
component the y-axis, right?
yes,
And if you assume some positive charge, always I said, you are still not getting the method. So this entire charge will repel. So in which quadrant the answer will be? Or let's not say the quadrant, in which direction the component will be. So the X component will be in the X direction. And what about the Z component?
That direction.
Z direction, I'm sure.
Negative.
Negative. Very good.
Oh yeah. Uh-huh.
See, you need to realize that it is repelling, so it is going to be somewhere here inside. I mean,
Yes, sir.
until you are not able to see this, you can't answer this question for sure. So it will have the value k lambda by r, and I cap is one component and minus k cap is the other component, and we are done with the first part. For the second part, which is having the semicircle, we know the answer will be only along the minus y or plus y.
Minus.
Minus.
Minus y. So, and the value will be twice because it's 2k lambda by r.
Yeah.
So we can write as 2 minus y. The k lambda by r we have taken common. So the second part will give you this answer. And the third part, which plane? XY plane. So it will have the component x and y. So which direction it will have the component?
Negative x,
Negative.
positive y.
Negative x and negative?
Negative.
Negative x and?
Positive
Y.
y.
Once again, negative x and
Positive.
Positive y.
positive y. It's negative x and positive y is the right answer. I mean, okay, how many of you are not getting the answer? Like you're playing some fluke actually. You have no idea what is happening. Put a plus charge, take some random point on the wire, think of the direction, you will get the idea which quadrant I should take. Or go back and revise how we take the field of the semicircular wire, semi-infinite wire. No, that's straightforward. I mean, if you're not getting the direction, then you're not learning this part actually. So this is k lambda by r, and now we can rearrange. It's I minus 2. Sorry, this is 0. No, I cancel out. Yeah. And j is how much? Minus 2j and plus j. Minus j, right? And k is how much? Minus k. That's it. So we have the answer minus k. So E naught finally turns out to be k lambda by r minus j minus k. So I can say the mod of E naught will be root 2 times k lambda by. Does it make some sense to you guys?
Yes.
Yeah.
At least solve this question. See, if every time you're making mistake, it means you have not understood the basic concept only. You're not getting how we are finding the values and all. Okay, let's see. So I hope this time you get the right. Ignore the way I have done, but these are three quarter rings in three different planes, right? And I have to make it slightly interesting. I'll make plus lambda minus 2 lambda plus 3 lambda. And the question is same. Find E naught. Okay. So try this question. Questions clear, guys?
Yes.
So think carefully. First, you try to understand the direction, then answer it. Don't make it fluke. Okay, somehow plus minus, some random answer, and then say, "Oh, this is wrong. This is right." No, I don't want that. I want you to think before you answer. Okay, so 2k lambda. You can do one thing. Just take
Common 2k lambda.
yeah k lambda bar, and then just give me the last answer, like how much I, how much a, how much.
Yeah.
I wrote.
You sent.
Yes, sir.
Okay, you're okay. No, no. See, in the when you take I, j, k common, then square root will never come, right? You cannot have the square root because every component will create only k lambda by r. Hmm? So how the root will come? Tell me. You're writing the components, then why root is coming? So when you write the component, you cannot take the angle thing. No? You have to just write the component.
Yes, sir.
So rectify this and tell me the answer. You should also rectify your answer. Give me
Yes,
the
sir.
final answer.
I'm
Adit, are you trying?
Yes, sir.
Sir, I sent.
So it's k lambda by r 10 j minus 4k, right?
Yeah.
Okay. That seems correct. Can you rectify your answer?
Yes, sir.
So what's the new answer? You must take k lambda by r common and then express the other. Okay. First you answer. Let me ask everyone. Let me call it 1, 2, and 3. The one is positive charge, so it will repel. It means the answer must have the opposite quadrant, isn't it? That's
Yeah.
logical. So if it is in the yz plane, the answer must have minus y and minus z component. That's logical. Just without doing anything, you can tell the answer. But the number 2 is negatively charged quaterning, which means it will attract. So which quadrant or which plane?
Let's
So
say
number 2
y z plus I plus.
plus I plus z. Very good. And again, if you look at the plus 3 lambda,
Yes, sir.
it will repel, which
Minus I
means opposite
minus.
quadrant, which is minus I minus k. So
Yeah.
once you realize this simple trick, you can get the answer in no time. I hope this is correct. So repulsion means you have to take the opposite quadrant, and attraction means same quadrant. That's logical way of thinking, and that will make your calculation pretty easy. Okay. So minus I plus j minus 4k. Let me check which answer is correct. So EU I am writing as k lambda by r. I will take common because I know it's going to be common. So for the one, it will be minus j minus k. For two, it will be plus twice of I and twice of j, because it's 2 lambda. And this is minus 3 of I minus 3 of k. So the E naught turns out to be, so 2I minus 3I minus I, and 2j minus j is j, and minus 4. So I think Kanu has the right answer. I hope so. Yes. Minus I plus j and minus 4 is the right answer. So where you went wrong, Krish? Tell me.
Yeah, sir. I took this.
Only
Yes.
IJ, right? You didn't take care of the 2,
Yeah.
3, the coefficient. Right?
Yeah.
Yeah. And Aditya, where you are finding yourself in this part difficult? Like, what you're not getting it?
So I cannot like imagine like how the diagram looks in my head. Like to take the IJ and K components, I'm struggling like which one I have to
Okay,
take.
just this small practice will help you. Imagine this quadrant. Okay, only one at a time. Which quadrant is this?
This is first.
So if I have any charge here, it will be, if you put some charge at the origin, it will repel or attract.
It will repel.
So we have line of symmetricity, something like this.
Yeah.
So if this is the electric field, then what is the component in which direction? Minus x and minus y.
Minus one.
So the whole idea is every wire is in one particular plane. So you bring that plane into picture separately. You can draw that plane separately and then find the answer.
Okay, okay.
And you have to repeat this process for all, right?
Yeah.
That's it. Not very difficult.
Yeah.
So let me give you some other varieties of program that you need to practice. So I think we have done maybe not. So have you done the variable lambda for ring case, if you remember? So a question in which I mentioned that the lambda is a variable, and lambda is basically lambda not cos theta. I think this is a question I gave na, earlier.
Yes, sir.
Yeah.
Yes, sir. You did.
I hope you all have practiced enough to understand this, right? Uh, Not enough. Huh? So can you find the electric Plato again? Even though I have given, can you solve it again quickly? You know how to take element in solve this, right? So do this in 2 minutes. Just to check whether you remember the derivation or you only remember the results, because the results you will forget anyway. Derivation is something that we never forget. KL, okay, K lambda pi by 2R, right?
Yes.
And what is the direction?
So minus I.
Minus that seems correct. Yeah, that's correct only. Minus I is the right answer. Send me the solution, what you did. I want to see your method.
Yes, sir. Can I say?
You can send me on the WhatsApp, my WhatsApp.
Okay. One.
Take a photo and send me. And we got the answer?
Yes, sir.
How much?
K lambda naught pi by 2R.
Here I'm not P means pi.
Yes, sir.
Yeah. So, yeah, I think. Oh yeah, Krish, you are taking time to send me the answer.
Sir, yeah, I'm sending it to my mom and then I will send. 1 minute.
Okay, maybe. Okay, so you okay.
Sir, I sent.
It's not lambda not dl. It's lambda dl. And lambda dl is r d theta is correct. And how you got the when you write in the d formula lambda, okay, that's d value, right? Lambda, and where was the substitution? Okay, it's the right answer with the wrong method. I mean, many things are not correct. Like you cannot integrate the d first of all. You can only integrate the component, and why you wrote the component later on, and how you got the answer
Sir, I wrote
cos square.
direct.
No, not direct. I mean, everything is wrong. How it is sin theta? Tell me. How you got sin theta on the second time? And what do you mean by direct? What is the, how you got lambda naught in the very first step one itself?
Okay, in D first step we are talking.
Yeah, and also in the integration, how you got sin theta?
So
And how
I
sin
took
theta is equal?
components. I divided into two
Mhm.
components. D sin theta and D cos theta. I broke E
Yeah.
vector.
So how sin theta will come?
So D sin theta.
So how what is d then?
D is the elementary of E vector.
So what is lambda? What is lambda not here?
Sir, I think that must be lambda. By mistake, I wrote lambda.
Still, you need to rewrite it. Just rewrite properly.
Okay.
See, not just get the answer. There are many things which are blunder here. Make sure that you write everything with your thinking, not with you because you remember something and else. You're trying to just
Yeah.
somehow recreate that memory. No, don't
Yeah,
try to
I
recreate.
did try that. I
Yeah,
will do that properly.
do it to learn, not to just convince me that I have done.
Yeah.
I
Yes.
know, I know who is doing, who is just trying to recreate the memory and all. Do it again.
Yeah.
Okay, so those who have done, now time has come to go to the next part. So the heading will be electric field due to uniformly charged ring on its axial position. Okay, so this is your question. So what we have is a ring. So we have a ring. And the total charge given on the ring is Q. See, every time you will see, sometime I mention lambda, sometime I mention charge Q. Why we do so? Because from experience, we'll come to know that in different scenario, different assumption will let you express the answer easily. So that is the only reason there is no hard and fast rule as such. So this is the axis of the ring. It doesn't look like axis, but it is axis. This is the radius as r. The charge is uniformly distributed, which means the lambda can be defined easily. What will be lambda here? The charge upon length over which it is spread out. So what is the length over which the charge is spread out?
2 pi r.
2 pi r. It's full ring, right? And now we are supposed to find the electric field at a distance x from the center. on the axis of the ring itself. Okay. So here it's difficult at first, but if you just think of, again, what I say, every time you have a different charge distribution, think of elementary first. So if you take elementary, let's say I'm taking elementary here. And if I call the length as of this elementary as dl, the direction in which it will create the electric field at the point P will be like this, something like this, isn't it? And the direction of the axis is like this. Now, with your common sense, you can realize that which component will survive and which will cancel or which will vanish.
Yes, sir.
That's I'm asking. Which
Sir,
component?
d cos theta will survive.
So you mean to the say that the component along the axis will survive, right?
Yeah.
That is an, isn't it? So the component which is acting in the direction of axis will survive, rest will eventually cancel out. So although it's a three-dimensional, but you just let me show you one more point. If you take a diametrically opposite point, the idea will be much more clear that what is going to happen. So this elementary,
Sir, what is diametrically opposite?
pardon,
Diametrically opposite method?
means if you go across the diameter,
Oh, acha, the same point on opposite side.
uh,
Yeah,
they are
sorry.
called diametrically opposite, right?
Yeah, sorry.
Okay. So if we also assume that diametrically opposite point, we also get D exactly in a similar value and symmetrically. So these two will create the component along the x-axis, and that will add up, and the component which is normal to the axis will cancel out, right? Now this will happen for every pair of diametrically opposite point. Do you realize this? Yes or no?
Could you repeat?
Every pair of diametrically opposite point on the ring will only contribute along the x-axis, the rest will cancel out.
Yeah. Okay.
All
Okay.
right?
Yes, sir.
Yeah, so that's the whole idea. So now what we are supposed to do is we are supposed to only find the first find the d and then find the dx, which will be d cos theta, and then you will automatically realize what to be done. So you can assume the charge here as of now as a dq. Only required then convert into other format to integrate. But let's move ahead and see what kind of integration we need to do. So what about dE? How much the d we can write? Let's say the distance of the elementary from the point P is r. So can you guys tell me what is d here?
Sir, K dq
K.
square, no, dq by r square. dq by r square, not
dq
dq.
by
R square. No, r square. So r will be, small r will be r square plus x square.
very
Root
good.
of r.
And what is
square.
cos theta?
Cos theta will be x by r square plus x square. Root of r square.
X by r, right?
Yeah, x by r square.
So this will become k dqx upon r cube. Can you guys tell me what is the variable here? Is x variable for the derivation purpose?
No, sir.
No,
Is r variable?
no,
Is x variable?
no.
So what is variable here?
R minus X.
DQ is variable.
Only dq is variable.
Yeah.
And therefore, the net electric field will be integration of dEx, and that will only give you the kx by rq into integration of dq. And if you add all such charge, what will get? You get total charge. The answer is pretty much simple, kq x upon r cube. And now you can convert x into r into under root of x square plus r square. And under root power 3 means 3 by 2. Is this clear, guys? So this is a very famous formula and everyone
Yes,
is
sir.
supposed to remember this. So due to ring on the axial position, the formula is kq, the distance from the center of the ring along the axis upon the distance from the periphery to the point whole cube. Or you can write like this, kq x upon x square plus r square 3 by 2. Is this clear? So now this is very famous for multiple reasons. The first is if I put this implies ex will be how much, guys? So at x equals to 0 means you are at the center of the ring.
Yeah, 0.
So at the center of the ring, the electric field is 0 because of symmetricity.
Zero.
And yes. And then if x tends to infinity, then what will the ex tending to?
So 0.
Why?
X square is in denominator.
But power is 3 by 2. No?
Yeah, sure.
So what is the net power of the denominator?
3.
3. The effective power of the denominator is 3 and the numerator is only 1.
1.
So as x tends to infinity, the bottom will grow much faster than the numerator.
Yeah, so it will tend to 0.
Tend to 0. So when you begin, it's 0. When you end, it's 0. So somewhere in between, it must be attending some maximum value
Yeah.
or non-zero value. So having a ring, if we plot the y-axis as the electric field strength and x-axis as the distance from the center, and if we take the right as the positive direction and left as the negative, because if you go on the right of the ring, the field will be towards right, but if you go on the left of the ring, the field will be left only, and therefore because we have two different direction of electric field, so if we choose the right as positive, the left becomes negative in terms of graphical representation. Okay, so tell me, guys, at which point from the center, how far I must move to from center where I can expect the maximum value, because the graph, as we know, is going to be something like this. At infinity, it is going to be 0, so some asymptotic graph will be there. And on the left, graph will be having same feature but just opposite direction. So we have to represent like this on the negative y-axis for negative values. It's negative is not the value, negative is for direction. So left is negative, right is positive. We are taking this is positive. So you can see numerically somewhere it will attain the maximum value, right? So the question is at what value of x the maximum will be achieved. That's the question. Okay, solve this. Okay, what is the answer, guys? Tell me. Your electric field is how much? Your field is kqx upon x square plus r square, and we are trying to find the maxima as a function of x, right? At what x the, so what we can understand that E will vary with x. KQ is just a number, just some constant. So E is a function of x. So for maxima or minima, what we do?
d by dx is
D
equal
by
to
dx.
0.
D by dx. Yeah.
So d by dx we have to equal to 0. And I hope and believe that you guys can do the differentiation. If not, let me.
Yeah.
So this is the u by v relation, right? The quotient rule. So if y is in the format of u by v, so dy by dx will be v du by dx minus u dv by dx upon v square, if you remember. And if you equate this to 0, this will be v du by dx equals to u dv by. So always use this relation to solve the question. So it's like a v, the d in numerator multiplied by differentiation of numerator equals to numerator multiplied by differentiation of denominator, and then equate it and solve it. So I hope this is sufficient hint for you to start with, and hopefully you can get the answer. So tell me the answer. Yeah, that's right. So how much you got?
Tell me.
Yeah, 10.
R by root 2.
R by root 2. So x equals to r by root 2 is the position at which the field will have the maximum strength in value. You can also say minus r by root 2. Okay, both are right answer. Because it's only about direction. Okay. I hope this is clear, guys. Why it is so? If you solve it is coming r by root. Yes, Kanu, are you getting the differentiation part, or shall I give you the differentiation completely? If it is okay, or shall I give the solution? Tell me just. Hello, hello, 1, 2, 3, 1, 2, 3. Am I audible, guys?
Yes.
Am I audible?
Yes.
Yes, Kanu, tell me, is this okay, or shall I give you the solution?
No, sir, it's okay.
So similarly, can we do something more about this question? Like, can we answer some more difficult, challenging problems from the ring part? So ring questions generally comes with the concept of equilibrium. So we have seen that the field is maximum at r by root 2, and anything beyond right or left, it will be lesser value. So I will explain things only on the one side. Let me draw the graph, something like this. Okay. So imagine we have a charge, a plus charge here. So tell me one thing. For this positive charge, the ring will repel or attract.
Repel.
So imagine it is being repelled by the spin, by the ring. So to keep it at equilibrium, we need to apply some force in the opposite direction. Let's call it F. So F is the force at which the particle is at equilibrium. So here we have equilibrium, and we would like to emphasize or understand that this equilibrium will be stable or unstable. So how we understand the equilibrium is stable or unstable without mathematics? How we understand? So generally what we do, we displace right or left, right? And once you displace slightly, and once you displace slightly and check whether it is having the tendency to go back to the initial position of equilibrium. If a tendency is there, then we say the equilibrium is stable. But if the tendency is to deviate from the equilibrium position, it is unstable. So similarly, you have to test the same. So if this charge is given to you, you have to discuss whether the equilibrium is stable or unstable. Okay. So is this equilibrium stable or unstable? Anyone?
Unstable.
Unstable. Why? Because if I shift right, what will happen?
So the force will get larger, so it will
Yeah,
accelerate.
correct. It will go on the right only, right? And if I move towards left, what will happen? Then force becomes smaller, but the applied force is the same. F is fixed, and therefore it will go left until far away. Okay, so that's the whole idea. Now, if I just take the plus charge here, so let's call it case 2. So what are the case 2? Stable or unstable? So what kind of equilibrium you think it is? Same situation, repulsion and the force.
Stable equilibrium.
Yeah, it is stable equilibrium. Because if you go right, the force will decrease, but the F is still bigger. So it will pull back. But if you go left, then the FR becomes bigger, and so it will push towards right. So for positive charge, only right of the R by root 2 can have the stable equilibrium. On the left, it is going to have unstable. But it is not true for negative. In fact, it is just reverse. Let's make it case number 3 and case 4. So here the attraction will be like this. And to balance, you will apply some force. And again, attraction like this. So out of 3 and 4, tell me which one is stable and which one is unstable. Stable means if you displace, you should try to come back. That's mean stable.
So third one,
But one is what?
more stable.
Is stable. Yeah, right. Can you explain how?
So ring is positively charged, so it will attract.
Huh.
So it will go. So just as you said.
You're not able to explain. When you're saying ring is positive, everyone knows the ring is positive.
Now,
How
ring
are you
is
going to explain?
positively charged, so
Hmm.
the negative charge, if we move it towards the ring, then it will get attracted by the.
It is anyway attracted, but how you explain the stability? You are saying the charge is positive and they will attract if it's negative. Everyone knows. Explain the relation why it is stable and why it is unstable. Anybody who would like to explain?
So the force of attraction will get larger as we try to push it away. So it
As you
will
try to move right or left.
right.
Right. So if you move right from the stable, the attraction will increase or decrease.
Increase.
Yeah. So attraction is increasing and F is same, right?
Yes, sir.
So the net force is
Towards left. So
left. That's the
stable.
reason. Because you're trying to move right and the net force developing is left, so it is trying to bring it back. So it is in the stable. Or if you try to move left, it will be net force will be right. Because if you try to move left, the F will be stronger and FR will decrease, isn't it?
So
Is this clear?
can you explain again?
So you explain. I mean, I'm saying just think that how the forces are. See, F, what I'm writing F is a constant force. Let's say 10 Newton. F
Okay.
is constant. It's not changing. It is acting to keep it at rest for a given location,
Okay. So it
and
is
then
acting.
Fr is the force due to ring.
Okay. So it is acting to keep Fr constant. Okay, Fr in the same position.
It is trying to keep the charge in the same position, not Fr.
Sorry, it is trying to balance.
Yeah, balance. Yeah, correct.
Oh,
But it is trying to balance only at that position, not at other position.
yeah. Oh,
So once you displace the right or left, you have to check the net force direction. Okay. So once you check the net force direction, then things will be easy for you. Is this okay?
yeah. Okay, sir.
Okay. So with the ring, we can also have the Shm problems, which are very common. Again, this triple thing. So now, so we can repeat all those questions that we solved earlier. And let's say the ring is fixed. So we can make it movable also. Then you need to use the center mass concept. Okay. So the formula for the electric field at a distance x is how much? So the electric field due to the ring is how much? KQ. Tell me
EQ
this.
x by x square plus r square whole raised to 3/2.
Very good. So you just need to remember this. KQx by x square plus r square power 3/2. KQx by x square power x square r square power 3/2. Anyway, now for the situation when we talk about the SHM, we want to make it linear. So if x is much less than the radius of the ring, if it is quite close, in such case the EX will be how much? What we can write?
Q by r square.
AQ by
RQ.
anybody, what is if x is very small compared to r, what we can write? So from the
So we
denominator we
can
can
ignore
remove
X
x,
cube.
r into x. I hope this is clear to everyone.
Yes, sir.
So EX is how much? KQ by R cube into X. See, you cannot remove X from the numerator. Why? We can only remove compared to some value, right?
Yeah.
We
It's
cannot
not an
just remove,
addition.
yeah. It's not like adding or subtracting. So we remove comparing, and it is not being compared, it's simply multiplied. Okay. So EX is KQX by RQ. And now you can see that if a charge is kept, if you bring up some other test charge of value Q naught and mass M. So if you displace slightly, if Q naught is displaced slightly, what will happen? It will make this is minus. Sorry. The moment, okay, again come back. If you remember, anything from origin to r by root 2, this is the stable, and anything beyond the positive is unstable. So if the charge is at the center, is there any force? If the charge is at the center, we know the net field is 0. And because there is no field at the center, the force acting on the charge will be how much? 0 again.
Yes.
So the moment to displace right or left, what will happen? Will it be stable or unstable equilibrium? Can you guess? For a negative charge, if you displace slightly from the origin, the stability will be like, and what kind of stability is this? I mean, stable or unstable? Hmm? Pardon?
Stable.
Yeah. So once it is stable, so we can expect SHM or at least oscillation. So for oscillation, the only thing we need is stable equilibrium. We don't need a linear relationship. But for SHM, what we need? A linear relationship between force and displacement, or acceleration and displacement. If you remember, we have discussed this. So can you tell me the net force at a displaced position? No, I have a this. So if you displace slightly by x, so it will be attracted towards the center by the ring, and this will act as the restoring force. What is the restoring force, guys? What we can write? So force value
Ex
is
by
Q not into Ex, right? This is the formula for force on a charged particle, QE. So the answer is, you know what to written, KQQ naught by R cube into X. And therefore the acceleration will be minus of F restoring, because we are writing the vector equation. So whenever I write minus, and I'm writing the vector equation into X. For one dimension, we can put plus minus. Because acceleration is towards left and we are displacing towards right, and so the minus sign. So the answer is minus KQQ naught upon MRQ into X, comparing with the standard equation of SHM. You can see omega square is QQ naught 4 pi epsilon naught MRQ. I'm removing K in terms of this answer. So we got to, and therefore the time period is how much? I hope you remember the formula, 2 pi by omega. A similar question can be created using the gravitation. In gravitation, by naturally, by default, they attract, and therefore, so in gravitation, if you try to find the Gx, it will be Gm x by Rq. That's simple. And this term eventually becomes the omega square, because this is itself acceleration. So if you compare the Gm by R cube itself is the omega square, and therefore, so in gravitation we can do it like this. In gravitation, the G itself is the acceleration, and therefore you need no need to do further anything. This is the in gravitation. Is this clear, guys? How to solve question in electrostatics and how to solve in gravitation?
Yes, sir.
So there are many questions that we can solve again. Let me give you some questions. So let me put the question here only. So I hope you can read the question and let me do the diagram just for the. I hope the question is clear, guys. In case of doubt, do let me know. Okay. I think you're finding it difficult, right? For every SHM question, what we do? We displace by some value, right?
Yes, sir.
So if you displace by x, then this side it will decrease by x.
Yeah.
So the upper rod is r plus x and bottom is r minus x.
Yes, sir.
So now what we do is we only take the symmetrical, I mean, like the symmetrical point will cancel out, which means the smaller end is r minus x. So up to r minus r plus r minus x above, the effect of these two forces will cancel out. So this is left with how much? 2x. So only this portion will experience the net force. Understood? Whose effective distance we take as r only. Are you getting the idea what I'm saying?
Yeah.
X is very small. So whatever charge is present on the 2x length, which is q by 2r into 2x is the, you can say dq charge or whatever q naught charge. So this much charge will experience the net force, and the net force will be q naught into E at x equals to r, because the length of the rod is 2r, which means r is the value. So this we can write as q naught, which is qx by r, and the electric field at a distance x equals to r will be kq x upon x square plus r square power 3 by 2. And this is the restoring force. So it turns out to be kqqq. This r cancels out. And this is 2r square power 3 by 2, which is 2 root 2 r cube. This is the restoring force, and rest is simple. You can write as minus kq. So I know it's very difficult, but if you have understood, then it's really good. Anyone who has understood this part, like how I have done this and what I have done? Krish, Kanu, tell me guys. If no one has understood, I will explain again.
Yeah, got it.
Trying.
You understood?
Sir, 2 minutes. No, sir, I'm trying. I'll write it my own once. And I'm
Hmm. See, the ring will attract both, na? Both sides. So if the rod is exactly symmetrically placed, then the net force will be 0.
Yes.
So when you displace, it becomes asymmetric. So what we are doing is we're trying to remove the symmetrical part, and then whatever is left asymmetrically, only that part will create the restoring force. Do you realize this? That is the takeaway. The symmetrical part on the above and below will cancel the effect, whatever they are able to produce. So the part which is not symmetricity, I mean not part of symmetrical portion on up and below, that will experience the net force, and that is how much length? Only 2x length once you displace by x. That was the realization part. Now
yes.
tell me if you're realizing or not.
Yeah.
Clear?
Yes.
Okay. And then you can do further things. Okay. So the time period is, I'm not going to write further. So in a way, you're practicing SHM at advanced level. Okay. Next, the next part of a system will be when a ring and the bead is free to move in a free space, a gravity free space. So the ring mass is capital M and the minus Q naught mass is small m and the charge is Q. So if I displace slightly, both will oscillate to and fro. So it's like a two particle system, or you can think like a two mass with a block. Sorry, two mass with a spring, what I'm saying. So once you displace X apart from each other, the re-string force will act as a spring constant. And the re-string force we have already calculated the value. It's Q naught by R cube into X. So you can compare always with the spring constant. This is also a way of thinking. And the K effective you can compare will be this much. That's also a way of solving the question, which I never gave you earlier, but you can think this. And once you convert into the spring constant, the formula is 2 pi under root m upon K effective. That's the formula for a single particle. And for two particle system, the formula changes to the reduced mass upon K effective. For one particle oscillation and for two particle oscillation, and the mu is called reduced mass, which I have discussed many times, but still once again, which is the product of mass upon summation of mass. So whenever you have two particles which are free to move, you can always use this relation. So remember this relation, and then for our case, ring and point charge are free to move. In such case, the answer will be mu by K effective, which is mn by and K effective is so I'm leaving the answer as such. So these three varieties of STEM questions you will always come across. Okay.
Yes.
So you need to practice all these questions at least few times, and it's good to go and watch the SHM chapter now. I think SHM is already in YouTube. Watch it; it's very easy for you to understand and finish it off. Okay. So I think we are done enough with the ring, and we have seen a variety of situation in which the question can be arised. There are many more questions pertaining to the potential, but since we are not doing potential as of now, so we will not go deeper into the other programs until we are learning the potential part. So after the ring, the most obvious question you will be asked is electric field due to uniformly charged disk. Now, to solve question of uniformly charged disk, what we do? Very simple thing. Whenever you have a problem which are difficult, you have to look for the elementary part of the disk. So in every disk, what sort of elementary do we cut? So generally we cut like a ring. Okay. And once we cut a ring, the formula that we have already derived for the ring will act as the elementary formula. And using that formula, we have to derive the disk formula. Are you getting this idea? What I'm trying to achieve here? This is 3 virus 3. I don't know what is happening. Oh, I don't like this color. No. So I have to go to Asian pen to ask which color will suit this background. Any idea which color will suit? Maybe this one. Oh, see the error. See the 3 error.
Matrix.
Matrix error. I don't know what is happening. This is dangerous. Anyway. So now a disk is given, and once the charge is in the planar surface or over a surface, what we first in the first change you will see is the way we define the distribution, and what we define here is called the surface charge distribution.
Yeah.
And hence we need to define something called surface charge density. And our answer is now going to be in terms of sigma. And, so sigma is the charge per unit length, right? Per unit area. Surface charge density, and it is defined as dq by dA. Okay. dq by dA. And if for uniform distribution, if it is said that the distribution is uniform, you can simply define as the total charge upon total area. That's simple. Only when it is a non-uniform, we write the elementary format. So we write dq equals to sigma into area which you have cut as an elementary, and then use this to derive every formula. But in the given question, the sigma is already given, and the ring formula is going to act as the prerequisite. So anyone trying to derive the formula, first you need to remember this. What is the ring formula, by the way? What is the ring formula? A ring of radius r and distance x from the axis. So how we write?
Sir, KQX by
X
X square
plus
plus
R square raised to 3 by 2.
3 by
Right. So you have to repeat this formula maybe 1,000 times in your brain so that it becomes the part of your brain always. So now this formula is elementary. So when you make an elementary ring, what will become elementary among all these formulas? What will become elementary? K will remain K.
Yeah.
Sir,
K.
R,
X will remain X. X will remain X. R, which R? So R will become variable, right?
yes,
So R will become variable. Let's change to R square, because we can talk about any random R. What about the charge Q? Can we say Q here?
sir, DQ.
DQ. These are the small changes you need to learn first. So you're going to make some elementary. How you take elementary? You move R and cut dr, right? That's how you make elementary. I'm drawing it just big enough for your understanding. So you move R, and after moving R, you cut a elementary dr, and this is filled with charge. And definitely it will not carry the entire charge of the disk. It will carry only a fraction of the charge on the disk. And therefore, whatever charge will appear on this elementary, we have to call it dq. So the question will change from a ring of charge q to ring of charge dq. Distance is x, and the radius of this ring is small r by y. because every elementary which will cut will have different radius. So R is a variable. Now we know the formula for this ring. So can you substitute dq in terms of the variable, a proper variable that you have to think about, and then do the integration to carry out the, I mean, contribution of entire disk, and then add them, or so every ring which will cut will create the field along the x-axis, isn't it? So direction is not going to be the issue. Every ring will make the field in the same direction. So contribution due to every elementary ring will add up, isn't it? And we are not supposed to do the vector addition and all here. We can just do it just like that. So can you guys now use the formula that we have here and replace dq by the suitable variable which you have to decide, and tell me the answer. What is the net electric field at the point P? I'm giving you 5 minutes to solve, then I will solve. And for today, I will end with a disk only because I have to do other lecture today. So try this out. Okay. 5 minutes to solve. 5 minutes, after 5 minutes, I will solve. And express the answer in terms of sigma. Okay. Sigma is known thing. Yeah, done. Anyone? Done, guys.
Sir, in term,
Hello, hello, 1, 2, 3.
hello, sir. Hello,
Am
sir.
audible?
Yes, sir.
Hello, 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 1, 2, 3, 1, 2, 3.
Yes, sir, you are audible.
Yes, Kanu, tell me. Have you done this?
No, sir.
So how to write DQ here? The elementary ring we have cut will have some area. What is the area of this elementary ring? How we write the area of the elementary? Perimeter into the thickness.
Yeah.
2 pi RDR. You can just stretch it. If you open it, if you cut and open, it will look like a rectangle of width dr, and the length equals to the perimeter 2 pi r. And so it's a rectangle. Area is length into width, which is 2 pi RDR. So once we know the area, the d we can write as k. The dq by definition is sigma dA, because sigma is given. Sigma into area is the charge on that elementary portion. X remains x, x square plus r square power 3 by 2. So in the derivation, x is actually constant because the point is fixed. The next step is substituting the dA value. So dE turns out to be 2 pi sigma k and then once you integrate, so r is the only variable, right? From where to where? 0 to capital R. Okay. And this is very nice integration because the numerator is having one power less than the thing in the bracket. It is x square plus r square. What we have here is r. So whenever the numerator power is one less than denominator, we know what to do. Differentiate the denominator. So let's take the simple way of doing this. Oh, I think you guys are not able to get the integration right. Is the integration problem? 90% case mass is the problem. So what you can do here, put the t square equals to,
Yeah.
or you can put t also, but that's
This is easier.
so if you differentiate, how to, what will you get? Can you tell me?
Two t is no, the 0 is equal to 2x plus 2r dr by dt.
X is constant, every constant will become 0. So 2 dt, 2t dt will become 2r dr, which means t dt is r dr. And now that's easy. So we can replace r dr by t dt. And the denominator is t square power 3 by 2, which is t cube. So this is simply dt by t square. And the integration is very much known, 1 by t. And the t itself is under root of. So eventually this will give you like this. So your job is done. Two pi sigma of pi I missed. And limit is from 0 to capital R. You can reverse it. So you can make it positive, and that's simple logic. And the steps is known to us. Upper limit. So R is the variable. So put R equals to 0, you get 1 upon root x square, which is x, minus lower limit. And now x is something which you can multiply inside. And not only that, k we can attach 4 pi epsilon naught. X upon x becomes 1. And the final answer that you should remember, the format in which you should remember is sigma by 2 epsilon naught 1 minus x upon x square plus r square. So this is what you need to remember. Okay, is this clear?
Yeah.
So I'll give you a different way of derivation for the same question. That's very uniquely defined for the disk. After learning some advanced concept of solid angle. Okay. So now once you know this, the homework that you can solve now is. So the first homework is. So we have uniformly charged hemisphere. We have uniformly charged hemisphere or hemispherical shell actually. Hemispherical shell. The radius is r. I mean, of course, you can assume. And because it's a surface charge distribution, sigma is the distribution value given, and sigma means the charge per unit area is uniformly distributed. That's why sigma is constant. And you are supposed to find the electric field at point O. You know what to be done, the kind of elementary you need to take. So think about it and solve it. Okay. So now you can solve most question of S. Verma except the potential part. So as of now, again, you can relax for some time. If you have finished up to 34, 35, relax for a while, then we'll do some more theory and then more questions. So today I'll stop here only. We'll continue next lecture a bit longer than today. Okay. So bye and take care. And now your job is to do the derivation practice. Every derivation that we have done so far, every derivation which involves some sort of integration, please do it again and again and make sure that you have mastered it, and make sure that you are able to finish the derivation itself in 2 minutes. If that speed has achieved, then you can stop. If it is taking 10 minutes to derive, keep on doing. So you have quite a lot of formula to be derive, because we have done a lot of derivational based question. Make sure that you have a command over it, and maybe I will take a random question. I'll give you a random question and you will have to solve in exactly 2 minutes. Same question. The same question which I have given, not something new. So practice enough to make sure that you have command and you can perform the same calculation in 2 minutes. So repeat 10 times or 200 times, I don't care. Because if you don't do it now, again the same problem. The entire magnetism is derivation. The entire EMI is like circuits basically, but still it is having some derivation. So these 2 chapters will be really difficult for you if you're not good with the derivation. Current you will be again having derivation, a lot of derivation. Okay. And once you're doing the derivation of these chapters, almost you can see there is a repetition of derivation throughout the physics. So master it once and then be relaxed for the life. All right. So bye guys, take care. I'll share
Sir,
the
on Tuesday, could we have a class a little early? Because I have class from 8 to 10.
8 to 10. Yeah. Kanu, do you have time constraint on Tuesday? Can we keep around because even I was trying to keep it early, bit early, maybe like 4 o'clock.
No, sir, I don't have time constraint on Tuesday.
Okay, so we can keep it from 4 to 8, like 4-hour lecture.
I will have to ask ACM, he hasn't scheduled lecture yet.
Okay, so you can keep it with, tell him to keep it before 4 if possible. If it is clashing, then let me know. Okay, I'll schedule it.
Okay.
Okay, so all right, I will not commit right now. I'll wait for Tuesday morning and
Yeah,
then
sir.
we'll start. Okay, bye guys, take care.
Bye. Thank you.
Bye, sir.
Yes, Krishi, inform all that I'm coming at 8:30 to 8:45. So come early only. Okay.
Okay, sir. I will also. Okay.